I'll be sharing my screen. Himarashmi, is it visible to you, my screen? Himarashmi?
Yes, sir.
Okay, that's good. Mute, immediately mute. After responding, immediately mute. Okay. Now look at that. This is the Google class. As many as only 54 people are part of that. If I look at here today, it's around 100 people have joined, right? All those belonging to A division, I wanted them to give email IDs to Himarashmi and Manoj, and it will be a Google class link will be sent to them again once again. Now, if you look at that, there are different sections here, right? Assignments for CT and laboratory activities. There are three assignments have been given. First one is theoretical things. Second one is a lab exercise. Today we'll see that what is this lab exercise, first one, right? And related programming exercise. Here this assignment is on writing a C program to study the command line arguments in C language. This is a very important thing. Then display the process ID of a current running process, right? Then show the use of fork system call to create the process, right? This, and there are self-learning exercise added to that one, which you'll be doing it slowly. You should be in the position to learn on your own and provide the solutions. That is an ultimate goal or aim of any education. These are the three parts makes assignment number 2, which you'll be doing today, tomorrow, day after tomorrow. Okay, and on Sunday, you'll be submitting assignment on that. All program, everything is given here. Hand holding is given here. And report is to be, okay, it goes like this: cover sheet. It should have a college type name, department name, institution logo, course code, course title, USN name, your name, email ID, mobile number, assignment description as a cover sheet, right, with a proper border. Then index sheet will be there, and the content will go author, your name, date of submission, problem statement completely, program listing, right, with the line numbers and all. Then finally sample input output for all possible scene, right? In the sense, a given program may have multiple inputs resulting into different kinds of an output and all, right? And references, whatever you have followed. This is mandatory. Page number must be labeled as X of Y, that is 1 of 5, 2 of 5, 3 of 5, 4 of 5, 5 of 5, assuming that the total number of pages are 5. And use uniform font size and style. This is a generic brief, okay, description about how a PDF report you'll be preparing. It's a soft copy typed version, right? Thus, okay, you have to go through about that, right? So here, before the program list problem statement, you can write something here. I'll add one more section here. It is about, it is mute all your mic, all those who are, I request all the people to mute their mic. Here, okay, about the principles slash theory. Okay, the principle or the theory associated with this particular exercise that you will be doing it. This is the first exercise, right? So we will get into now. Look at that class coverage, that video or whatever consent is there. I'll be adding it. That lab session today, it is this. I'll be adding it once the class gets over. Then now look at that learning materials and programs given to you. History of Unix are given to you. That will be first exercise submission, but you will be referring to the internet and making a comprehensive report on Unix evolution. Now VI editor and Unix command, later we will see that. Now look at the command line arguments. First thing is about the command line arguments. Then program to display process ID, then to display the process ID and parent ID, then use of fork. All these programs have been given here, which you will be exercising this. I'll run the program and I'll show it also. Now let's look at the command line arguments. Right, when you click this command line argument, you will get a program here in the PDF versions. Look at that. Again, we'll run this program. Hope this is visible to you on the screen. So you have a include stdio.h, line number 1, then int main, function returns integer value, success or failure. And ARGC and ARGB, ARGB, okay, is, okay, and it is an array, okay, it is an array, right? That's containing different arguments. Got it? That's so it is an array of pointer to the character. It is an array of pointer to the character. Then I mean, you are simply displaying message on that. Then depending on ARGC, how many counts are there, right? For I equal to 0, I less than ARGC, you know about that, I plus plus, right? Then you are displaying I as well as ARGBI, right? This you display, right? Now I am showing here any command line arguments that you pass it, that this program is going to display. I'll run this program also and I'll show to you. Right now, look at this. How do you compile it? Now, the name of the file, okay, this is, okay, command line arguments, 5 dash command line arguments dot C, right? So, what we'll do is cc minus o, and name of this is a name of the executable file. It could be anything. Okay, if cc minus o and name of the executable file, if you don't give it, it will take a dot out. Hope you all people know about that. You want to name, okay, give a name for command, I mean executable file. It is better, it is a good practice, you name it, right? Then you are using minus o, okay, name of the executable file. Then you are, okay, the name of the C program source code, right? In this case it is a 5 dash cmd linearguments dot c. Look at that, wherever, right, the capital letters is there, accordingly you have to give it. So once you type this, it generates a, okay, executable file with the name whatever you are given here, the highlighted one, and you are typing this, right, dot forward slash. I wanted you, what is the meaning of dot forward slash? Studied in the next session. I'll be asking you what is that. So name of the executable file, cmd linearguments, right? I'll do it, and I'll give, okay, a parameter during the, okay, as these are called command line arguments, right? So when you run this program, you look at that test program is a message. You will get the message test program on the screen like this. Then first argument is a name of the executable file itself, name of the executable file itself. Then argument 1 is, right, whatever you have passed here, UPK, GPK, MPK, PMK, RPK, all this is argument 1, 2, 3, 4, 5 that it will display. This is necessary. This is necessary. This program, simple program, is necessary for us, okay, because we will be studying so many other things about this command line arguments, right? I hope that one you understood this. So now we will get into a Linux environment, run this program and see this. So I told you that one you'll be using the, okay, you'll be using, right, VMware. Within that you have installed Ubuntu, Fedora, Red Hat Linux, or whatever that is there. This is mandatory. Running the program in, running the program in Unix is mandatory. It doesn't run programs in, okay, Windows environment, right? Most of these things. Now I have kept these things ready. Environment, I'll show you. SDMCET, right, is a username. I'll get into that one. So I'll open now the terminal, right? Terminal, I'll open it, right? And this terminal, right, I'll be running the program. So all my programs are available in the folder on the desktop. I've kept it. Wherever the folder you keep it, within that you have to get into. So C Unix, okay, UPK 2017-18. This is the, okay, the folder in which you do it, right? I'll open this. There are many programs, okay, I'll be using it. So what I'll do is command line arguments, fifth one. I'll open this, click this, and in a, okay, default editor, this particular things it opens, right? Now see here, right? So I have a test program, for loop displaying argv I, for I equal to 0 to argc. Argc stand for argument count. Argv, it is a pointer to an array of character, right? Argv is an array of, sorry, Argv is a pointer to an array of character, right? Thus Argv is an array of pointers to a character, right? This. Now look at that. You compile this and pass the parameter. This is a kind of an output you get it, right? So this is the sample input output number one. If you have a multiple sample input output, you can keep on writing it here. And this is how you will be taking printout with line number. And on the top of this, okay, here on the top of this, you'll be writing author, problem statement, okay, principles or the theories, all the things you'll be writing it here about this particular program. So that will serve as a good reading material for you, right? So this is about the program. Now I'll open this. So how do I compile? I change it cd, change directory to desktop. I change it to this folder. This is there in cd, c unix upk 2017-18. This is the folder I kept it. So thus, now when you look at that, ls minus l, all the commands you need to go through. It is directory listing, right? So you'll find all the programs that is available here, right? So whatever it is, clear the screen. I'm clearing the screen here. Right now, I want to compile. I told you that you have to remember the name of the file, cc minus o. It is not zero, minus o. I want to give a name for the executable file. So what I do is I'll give a short so that I can remember easily and run it. This UPK is the executable file name. I'll be using this to run. But what is the source file name? It is the file dash cmd. L is capital line, then arguments A is capital, UMENT dot C. Please look into that. Okay, it is properly spelled here, right? So I compiled. Now UPK is the file, executable file available, dot forward slash UPK. I wanted you to tell in the next class why dot forward slash. Why dot forward slash? What is the meaning of this? I wanted the CR to note down this question. I'll create a Google, I mean, doc file and send it to you where all these questions will be listing there. That will serve as a question bank which will help you to prepare. Not on this. Why did the dot forward slash? What is the meaning of this? So when I run this, I need to give a command line arguments. Command line arguments, I'll give X, Y, Z, okay, whatever that is there, the command line arguments, I'll give it to you, right? So I press enter key here. Now look at that. Okay, the program here, test program. Okay, you are seeing this, right? Test program that will appear. Then name of the executable file itself is the zeroth argument. So in C program, the array begins with index 0. Okay, that is the first argument is 0. Right, zeroth argument is the name of the executable file, then first argument, second argument, third argument, all these things will appear on the screen. This is how you execute a program, right? Now I will get into other programs and explain, and in the same line you have to execute. All execution is to be done in Unix environment strictly, right? I hope that you understood all these things. So now I'll minimize this. I'll get into a Google class. There are as many as 67 students have participated, right? This is the first program you'll be trying today. All these things you have to try today, tomorrow, day after tomorrow by evening. You have to submit, okay, the laboratory exam, whatever the program you do in a particular format. Decide the cover sheet. Okay, guidelines are given to you. That's about the okay command line arguments. Now I wanted to display the process ID. Simple program I given to you. Try this. Hardly few lines. Now in Unix, every program when you run, it's called process. Process is nothing but a program in execution, right? It is given a unique ID and is being referred as PID, process ID, right? Now look at that. This is the program itself. I wanted to know the process ID of this program itself. So how do I do? I declare a variable called int PID. Then PID equal to, there is a system called get PID, right? Get PID, right? then you are displaying the PID value. So when you run this program, I told you how to run the program, how to compile. I'll not repeat. So assuming that 3 dash process ID is the name of the executable program, dot forward slash, then it will display 5154, right? Thus, right? And this will be different every time you run the program. When the program terminates, this process ID no longer remains that one. So this you will be studying that one, right? And along with the standard process IDs available, study self-learning kind of things, right? You go through all these things about this. Say, how do I get a help in okay Unix environment? I'll take you. Now there is something called manual. Manual in this is called man, right? What is that I want? Get PID. Get PID. I wanted a help for that. If it is the detailed synopsis is available in manual, it will tell you. Otherwise, it doesn't. Now look at that. Man get PID. When you do it, it will display the okay details of that. This is called okay synopsis, right? Name is get PID, and other related things get PPID. We will see that, and you need to include okay types.h. Okay, this whatever the file. Okay, you have to include libraries that will tell, and it will give a description. Get PID returns the process ID of the calling process. This is often used by routines that generate unique temporary file names, right? Get PPID return the process ID of the parent of this calling process. That is a very interesting thing, right? That is a very interesting thing. That is another assignment. Okay, display the every process has a parent process, right? So in this, and every process, whatever may be the collections, it has a godfather, right? Who is that godfather? As a part of the self-learning, you have to find out, and okay, you have to tell me about that in the next class. And there is something error, what error it returns, okay, and what standard it follows, right? It is a POSIX 1 okay compliant standard. We will see that what it is, right? All these things it will say, and you'll be typing Q, okay, to quit this and come. That's how you can get help for every system call and every command that you use. For example, I wanted a ls, man ls. It'll get you what are the different option. Ls minus l. What is ls minus l? Okay, refer it here, right? Here it will get you all the details, right? All details, all options it provides here, right? So this is how you can get the help for any system call or any okay command, right? uh, this is about the second program. Okay, display the parent process ID. How to do it are given here. They're all small program which you should be in the position to do it, having learned a little bit of C programming. Given here as it is, you type it, it works, right? I'm declaring two variables, PPID, okay, and PID. P stand PPID, parent process ID, PID, process ID, right? Get PID, get PPID are the system calls. Here is an sample input output. You try and your sample input output, you display it. Right. Now other thing, okay, today we end with this. Okay, the lab exercise number one. 1 minute, I'll get into assignment number one is study, theoretical thing. But true lab exercise one, right? But in fact, it is a second assignment. It reads like this. You have to study the command and arguments in C language. We have done it. Display the process ID and parent process ID, both. Self-learning exercise. Modify this program to display the parent process ID. I already given a hint to you, right? Then show the use of fork. Okay, this I'll be explaining to you now, right? About this. Okay, now I'll get into right the program listing, which will help you, right? This we okay after completing this, right, the lab exercise 1 is ready, right? All this you have to do it, and you have to have only one report containing all these things. Exercise 1 description, exercise 2 description, exercise 3 description, all this. Exercise 1, okay, command line argument. Exercise 2, displaying process id. Exercise number 3, parent process id displaying. Exercise 4, okay, fork. There's all this 4 in single pdf with a single cover sheet with a single index, and contents are different. You need to submit it on Sunday afternoon, evening. Now let's look into that. Fork, right? What is a fork? Fork is a system call which is used to create the process, right? We call it as a process, parent process, and child process, right? So now when I use fork, it creates one more process. What is the process? Process is nothing but programming execution. It creates another child process. It creates a child process, okay, and both code, okay, the code from the immediate line will be executed by both parent and child process. So what is the immediate, okay, code after this line fork? It is I am executed by both parent and child. So whatever the program you write, everything will be executed by both the process. That is this program that is called parent and its child. Both it execute. But how to know about the child program, parent program, and all that we will see it in the next laboratory. Right? When you run this program, how do you run this program? Right? Name of the executable file dot forward slash. When you run it, there will be a parent process initially, right? When this line is executed, a child is created. When a child is created, what happens? What is the memory layout? Right? What is its ID? I told you every process has its own ID. What is its ID? What is the parent ID? Parent ID in the sense this program. So now you know, by doing the first two programming activity, displaying parent ID and process ID, right? You can find it out. And little bit self-learning you do. Some of the things are hidden here. That I'll be telling you later. But in advance, when you're doing, you have to play around this, try to know, okay, how do I distinguish a child from a parent here? But now here I'm not distinguishing. The line that follows this fork here, printf, this is executed by both. No, I don't want this. I want child to execute something, parent to execute something else. How do I distinguish that? That is self-learning activity. If not, in the next class, I'll be telling about that. Right? Thus, so I am executed by both parent and child process. This line is executed by both parent as well as child. So there will be two output. Right? Look at this. One of the when you execute this, immediately you get an output. I'm executed by both parent and child in this scene. And parent program terminates so that you get dollar prompt here, right? But the child is also there, right? Who is executing? Whether the child executed first or the parent executed first, we don't know. What is the order? In what order it will do, right? That we have to see it. Then look at that. There is another output. One is from the parent, and there is from the child. But okay, which output belongs to who? Which one? We don't know. That how to modify this program. That we will see it in the next class. So it is this much doing is enough now, right? Then in the next class, again next laboratory session, though it is a lab 2 activities, right? Or today you can try, right? Modifying this program, saying that, okay, the fork will return a value. What it returns a value based on the return value, you can write if then else and modify this program. In case of parent, some value is different. In case of child, something is different. Using that, you can distinguish parent and child. And instead of saying that I'm executed by both parent and child, okay, you keep it. And one more message you can add, I am child process. A child will say I am child process. Parent will say that one I am a parent process. And both will say that this. How do you distinguish that? I'll give a hint. Return value of the fork, you have to take it, and child return value is different. For a child, value is different. For a parent, it is different, right? Use that one. If return value equal to this, it is a child, displays a message. Otherwise, the parent displays a message. Terminate if then else. Then keep this as common at the end of that, right? Thereby, modification you can do. Do the modification. Modified program, you have to submit it. Please remember, when you do the program on your own, okay, otherwise, if I give a program everything and you do that one, what is the use of that? This is the hand holding. Basic things are given to you. You have to modify this program so that child will display that I'm a child process. Parent will display that I'm a parent process. And both, when they terminate, they'll say that when I'm executed by both parent and child, this message also you are keeping it. Are you getting this? Right? So this is how things are to be done. So I'll go back, right? Then the laboratory 2, next week what we do, that also are given it here, right? And some more things I'll add it, don't look into that. So you'll be seeing now, right, command line arguments, program to display the process ID, program to display the parent process ID, and use of fork and modifying that fork so that the program looks better. When you modify, your two learning will come. When you execute the same program already are given, you become a typist. So every exercise, basic things I'll give to you so that you need not run here and there. Then modification will be told to you in the video. You have to do modification. Or if you wanted me to write it this, right, I'll put it here. I'll put it in this lab exercise 1 itself. I'll edit this, right? I'll write it here as a part of self-learning exercise. Okay, 1 minute. Modify the given code so that child and parent will display different messages. Yes. Also, both will display common message. This is you have to learn, and based on that, okay, you will. There was one question in gate examination. What is that? I will share with you tomorrow. I mean, in the next class. So this is the change. So there will be self-learning exercise, this one, that you have to do it. I'll be saving this, right? So you have assignment number 1 already, okay? Assignment number 1 is a study of Unix, take some more time. Assignment 2, right, is of programming today, whatever you have gone through. I wanted everyone to do beautifully, prepare the report PDF, okay, having a cover sheet, index, and contents for all smaller activity, whatever are given, all this, and then given in ABCD, whatever it is, all preparatory exercises, and the assignment 2 description, whatever given ABCD, you'll be writing it, right? So this is about the laboratory today. Now everything is available to you. Go through that. Under Unix environment, you'll be doing it. Today is a Friday, tomorrow Saturday, Sunday. 3 days time is there. Every time hereafter, 3 days time. Friday is your laboratory. Friday, Saturday, Sunday. Okay, physically when you come here also in the laboratory you are doing it. Then you have a time, do it. And on Sunday you'll be doing submission. Every Sunday of that week you'll be doing some submission, right? And I'm scripting in such a way that the volume of work, okay, within 1 or 2 days you can do it. This hardly take around, okay, 3-4 hours, because you are new to the Unix environment. If you are familiar with a Unix environment, then hardly it takes half an hour to 30 minutes, 45 minutes, right? So please do all these things, right? Now back to the if you have any doubt, anything that you want to question, put it in the chat box, and see our Himarashmi and Manoj will be reading that and telling me. I'll be telling the answer to them. So with that, from my side, I completed this. Back to the floor. Back to the Himarashmi and Manoj. Anything that you wanted to tell? You can unmute your mic, Himarashmi, and all other people. As many as 63 students have participated. You can ask the question. Himarashmi.
Yes, sir. Sir, Shambhavi is asking, are ID and the address the same?
What is that?
Shambhavi is asking, are ID and address the same?
See, process ID. I told you about the ID. Process ID. Process ID is different. When you talk about address of what? Address of what? Address of memory location. Address of variables. That is a memory layout. That we will deal with that separately. Here is a process ID, unique ID, integer number, right? 1, 2, 3, 4, 1000, 2000, 3000, 5000, 8000, something operating system will give a number. That is ID we are talking about. That addresses of the memory locations are different. They are nothing to do with us. Hope Himarashmi have answered your question. Next. Himarashmi, next question.
Yes, sir. Sir, Sunidhi is asking, what is processing ID?
Processing ID, it is not processing ID, it is a process ID. So when you run a program, the running program is called process. So when there are several programs running in Unix environment, because it is a multi-user, multi-programming environment. I can run Java program, I can run Python, I can run C, I can run C++. Different users, thousands of users are running. Right? Every program which is running called process, every process is given an ID so that it can manage properly. It is similar to your roll number given or university seat number, USN, given to you. So all students are uniquely identified by USN number. So all program running in Unix operating system is uniquely identified by process ID. We will see that very soon. The process layout, memory layout, and all that things we will see it. I think I answered to your question. It is similar to your USN number given by university. Unique. Any other question, Himarashmi?
Sir, the next question is, what is child and parent ID and how are they different?
Yeah, how are they different is by process IDs. Child will get a different process ID. Again, this is different, right? Then the parent and child. My father is there. My father is a parent. I'm a child. Same relationship holds good there, right? And that is a part of a self-learning. How do you distinguish parent from the child? Return value. Are you getting it? Fork returns a value using that hint I have given, that you have to try in the laboratory by referring manual. I given a basic program, and the self-learning activity is that how do I distinguish child from parent through return value of the fork. And child, its ID you display, parent its ID you display, child its parent you display, and parent its parent you display. Everyone has a parent. Even parent has also parent. Got it? But in our context, my running program is one. My child is one. My child is, I am a parent for my child. But I am existing my program. For that also there is a parent. We'll see that layer, layout or the hierarchy of process IDs separately. Got it? Any question, Himarashmi? I think I
Sir,
answered.
Priyanka wants to ask, what do you mean by command line arguments?
Command line arguments in the sense when you run executable, a dot out you run. right? Then program runs within that. Okay, printf, scanf, you do enter the value of a, you give it. But I don't want to do that. Okay, at the time of running the program itself, there only I wanted to give the values which program will use. They are called command line arguments. So a dot out, there only give 20, 30, 40. My program will use 20, 30, 40. Instead of saying that enter the value of A 20, enter the value of B 30, enter the value of C 40. Rather than that, I'll give when I type executable code, there only input I give, my program will read that. So when I give the values at the time of typing the executable command, my program, they are called command line arguments to the program. Are you okay? Himarashmi.
Yes, sir.
Okay, that's
Sir,
good.
there are no more forward questions.
Okay, if there are no questions, thank you. Get into Google Class. Hope Google Class, okay, is giving enough material for you. Enjoy programming. Do programming on your own. Play with that. Modify the program. Add something more. Right? Then you are okay. Proper mute. All of you mute your okay mic. All of you mute your mic. Right? This is the protocol to be followed when a question is asked or otherwise entry. First thing is mute. Right. So enjoy programming. That will help you to prepare for placement. This is one of the important topic, whole course for placement. Got it? Okay. Himarashmi, in that case, can I stop? Can I stop today's session?
Sir,
Manoj,
sir, who doesn't have laptop, how should they do the assignments, sir?
they should have a laptop. If they don't have a laptop, study all the things. Mute your mic. Mute your mic. Manoj, mute your mic. Okay, check that one. There is a noise getting added through your system. Check it next time. If you must have a laptop. If you don't have a laptop, study that one theoretically. Keep ready with you. When you come here, you will be overloaded. Quickly, you will be doing all this exercise. Right? This is the only solution, and there is no other solution. There is no other solution. Right? From October 1st, when you come here, probably we'll arrange an extra slot in the night, evening, every day evening, right? You'll be doing uh, this course, data structure course, any other programming course you have it, you'll be doing it. There is no other go. There is no other go at all, right? Either take a laptop or ask your friend to give a laptop, okay, with the Unix operating system, do it there. If not, we will take care of you. We'll arrange everything, right? So in the evening, we'll have an extra laboratory. Okay, you'll be doing all the things. But still, you will be theoretically playing with that and trying to know this. I think I've answered to you. Shall I close this session, Himarashmi?
Sir, I wanted to ask one more thing.
Please.
What do system call actually mean? Are those like call functions?
Yeah. See, when you use a library, printf, scanf, they're all libraries. They're also functions. They're calls to the library. But see, your library, okay, you wanted system calls are nothing but, okay, they are the calls available through which the operating system functionality you can access. How, okay, my program can access, okay, the functionality, okay, provided by the operating system so that underlying hardware, underlying services can be used. It is through system calls only. Collection of system calls are the entry point to the services given by operating system. Through system calls, operating system provides services so that, okay, the application program or system program or compilers can use operating system services. Are you getting it? When you run a program, how do you run the program? I need a system call. I want to know my USN number, I mean process ID. Okay, operating system provides get PID. So use it so that you get it. So you are an end user, you are an application program, you are a system program, all that things you have to make use of system call to get, okay, services offered by operating system. They are the entry point to the operating system for the use of their services provided by them. Himarashmi, did I answer your question?
Yes, sir.
Good.
Yes, sir. Thank you, sir.
Any other questions? Otherwise, we'll stop.
Whether that get PID function is an inbuilt function or what?
They are called system calls. System calls provided by operating system. System calls provided. Okay. They are similar to your printf and scanf. But your use abroad. So this session is getting terminated in next 5 minutes. Right? So like a printf and scanf provided by your library, C library, right? So similarly, these things are provided by the library provided by things. You have to include that file and then use this. That's why in manual you'll find that one synopsis what all the files to be included so that the appropriate system call can be called. Without including that file, you cannot use the system calls. They are all readily provided by as services by operating systems. Shall I close this? Shall I close?
Sir,
Shall I close
so
this?
some people want, so some people are having issues in installing Ubuntu and running it. So
You
they are
have
facing errors in it.
now you have to clear that. Call the people who have given you laptop. They will help you. That is also learning. Otherwise, I'll create one. Say material how to install. It is simply when you get that image, it will keep on doing installation properly, right? But anyhow, I will create one learning material for that and make it available soon to you. But meanwhile, call the system administrator, or you can call people who have supplied you the system. They will help you to install this operating system. They will help you and try to know it. Okay, the session is now getting closed. Remaining all questions we will get into in the next class. I'll stop sharing the screen. 1 minute. Okay, thank you. As many as 63 people have participated in this. Right, please go through the Google class. Right, I will end this meeting. Thank you one and all. Enjoy learning right on your own, self-learning. Thank you.